With computer games, you play by running, jumping, and finding secret things. With algebra, you play with letters, numbers, and symbols, and you also get to find secret things. Algebra is great fun. You get to solve puzzles. Now, what is the missing number? Okay, the answer is 6, right? Because 6 minus 2 is equal to 4. Easy stuff. Well, in algebra, we don't use blank boxes. We use a letter, usually an X or Y, but any letter is fine. So we write X minus 2 equals 4. It is really that simple. That letter, in this case an X, just means we don't know this yet, and is often called the unknown or the variable. And when we solve it, we write X equals 6. Why use a letter? It is easier to write an X than drawing empty boxes, and easier to say X than the empty box. If there are several empty boxes, several unknowns, so we can use a different letter for each one. So X is simply better than having an empty box. We aren't trying to make words with it. And it doesn't have to be X. It could be Y, it could be W, or any letter or symbols we like. Algebra is just like a puzzle where we start with connecting like X minus 2 equals 4, and we want to end up with something like X equals 6. But instead of saying obviously X equals 6, use this neat step-by-step approach. Let's get through it. The first thing that we want to do is to remove the negative 2. To remove it, do the opposite. In this case, we add 2. Now, to maintain the balance, we do it to both sides, which gives us X minus 0 equals 6. Then we finally solve for X, and that X is 6. Now, why did we add 2 to both sides? Of course, to keep the balance. Just remember this, to keep the balance, what we do to one side of the equality, we should also do to the other side. Now, let's try another puzzle. Let us solve this one. X plus 5 is equal to 12. What we want is an answer like X is equal to something, right? But the positive 5 is in the way of that. We can cancel out the positive 5 with a negative 5 because 5 minus 5 is equal to 0. So, let us have a go at subtracting 5 from both sides. X plus 5 minus 5 equals 12 minus 5. Then we use a little arithmetic. So 5 minus 5 equals 0 and 12 minus 5 equals 7. And that becomes X plus 0 equals 7. Which is just X equals 7, right? Now, for our quick check, since X is equal to 7 and our equation is X plus 5 equals 12, it would become 7 plus 5 equals 12. And that proves the equation. And as we progress in our mission, we will focus on how to balance an equation when we are adding and subtracting them. Substitute means to put in the place of another. In algebra, substitution means putting numbers where the letters are. When we have X minus 2, and we know that X equals 6, then we can substitute 6 for X. So we have 6 minus 2 equals 4. An example would be like this. When X equals 2, what is 10 over X plus 4? Now we put 2 where X is. So we have 10 over 2 plus 4 equals 10 divided by 2 is 5 plus 4. 5 plus 4 is equal to 9. And that's it. Moving on. When X is equal to 5, what is X plus X over 2? Now we put 5 where X is. So we have 5 plus 5 in the numerator over 2. Then we simplify. That is equal to 5 plus 5 divided by 2 is 2.5. Then we add them together. So 5 plus 2.5 is 7.5. For the third one, what if we have X equals 3 and Y equals 4? Then, what is X squared plus XY? we put 3 where x is and 4 where y is. In this case, we have x squared, so we change it to 3 squared plus xy, so x will become 3 and y will become 4. So we have 3 squared, that is 9. Then 3 times 4, that is 12. So we add them, 9 plus 12, that will become 21. And for the last and final example, what if we have x equals 3, but we don't know y? Then what is x squared plus xy? First of all, we need to put 3 where x is. So we have x squared, so we change it to 3 squared, plus xy, so we change the x to 3, and y will remain the same. So 3 squared, that is 9, plus 3y. That is as far as we can get. As that last example showed, we may not always get a number for an answer. Sometimes just a simpler formula. And for our bonus example, when substituting negative numbers, put parentheses around them so you get the calculations right. For example, if x is equal to negative 2, then what is 1 minus x plus x squared? Now we put the quantity negative 2 where x is. So we have 1 minus the quantity negative 2 plus the quantity negative 2 squared, and that will become 1 plus positive 2 because negative times negative is positive. Then negative 2 squared, because when you multiply negative 2 by itself twice, you will get 4. So we have 1 plus 2 plus 4 is equal to 7. In that last example, the negative times negative 2 became positive 2. At the same time, the negative 2 squared became positive 4 because of this special rule that is shown in our screen. Learning algebra is a little like learning another language. Rather than using words, algebra uses symbols to make statements about things. In algebra, we often use the letters to represent numbers. Welcome to Puzzle Academy, the place where we can help you to build the pieces to the puzzle of success. Thanks for choosing to spend time with us today. If you are new here, we are happy to welcome you. Be sure to subscribe and follow us on Instagram at puzzleacademy.learn. The result of combining numbers and variables with ordinary operation of arithmetic is called an algebraic expression, or simply an expression. Algebraic expression examples are as follows. Expressions are usually named by the last operation to be performed in the expression. For example, the expression x plus 7 is a sum because the only operation in the expression is addition. Now, the expression x minus 3y is referred to as a difference because subtraction is the last operation to be performed. The expression 5 times negative 7 is a product, while 7 over b minus 3 is a quotient. Let us proceed now in our first example about algebraic expression. So, in this case, we need to identify each expression as either a sum, difference, product, or quotient. So the first given is 8 times x plus 6. In 8 times x plus 6, we add before we multiply. So the expression is a product. Another example, a plus b over a minus b. So in this case, the last operation to be performed in the expression is division. So the expression is a quotient. As we go on, algebra is defined as a branch of mathematics which generalizes the facts in arithmetic. In a spoken language, letters and punctuations are used to create words and phrases. In the language of algebra, letters along with numbers and operation symbols are used to create expressions. We shall begin by learning how to translate some of the rules in arithmetic and words into language of algebra. The language of algebra is composed of the following. The first one is numerals. Numerals is a word expressing a number, such as 0 to 9 and so on. The following are the common symbols used for variables. And the second one is the letters or variables to represent unknown numbers. A variable is a symbol which represents any number from a given replacement set. The replacement set is the set of values of the variable. Constant is a symbol which has exactly one number in its replacement set. Any numeral is a constant such as 7, 4, and 11. Even pi is also a constant. And last but not least, we have symbols or signs. There are many ways to express the addition, subtraction, multiplication, or division of algebraic expression. Some of verbal expressions and their algebraic expressions with addition and subtraction are shown in the following given. Let us divide the table into two parts, the verbal phrase and the algebraic translation. Now, what is the algebraic translation of the sum of m and 8? Very good, that is m plus 8. Another one is 5 more than t. The translation would be t plus 5. What if we have t decreased by p? Then we translate it to t minus p. Lastly, 9 take away d. What will happen if we translate it? And yes, that would become 9 minus d. Let us take note that in subtraction, you must be careful about the order of the number. Now, we proceed to the verbal phrases and their algebraic expression with multiplication and division. In verbal phrase, we have the product of 8 and m. The translation would be 8m. Another one, we have 1 over 2 of p, and if we translate it, that will become 1 over 2 or 1/2 p. Now, in this case, we have the quotient of 8 and m. The translation would be 8 over m or 8 divided by m. Another one is x divided into 10, and that is 10 over x or 10 divided by x. The multiplication sign is seldom used in algebra since it could be mistaken for the letter x. Thus, if we wish to express the idea of 8 times the number, we can do this in any of the following ways as shown in the example below. For two numbers, parentheses are often preferred over a raised dot, which may be mistaken as a decimal. Thus, 8 times 4 is expressed as shown in this example. The division symbol is rarely used in algebra. More often, we use the fraction bar. Thus, for a divided by b, we write a over b. In the following example, we let n represent a certain number, then translate each into an algebraic expression. Example number 1 is 9 more than a number. Have you noticed the keyword? Yes, the keyword is more than. So we use the operation sum, then the expression would be n plus 9. For our second example, 14 decreased by a number. In this example, the keyword is decreased by, and its equivalent operation is minus, right? So we write 14 minus n. And for the third one, 12 more than 5 times a number. The keyword is more than. Then the equivalent algebraic expression is 5n plus 12. We handpicked the next part of this video, and as we continue our quiz, you will be able to know the order of operations. Operations mean things like add, subtract, multiply, divide, squaring, and etc. If it isn't a number, it is probably an operation. But when you see something like this, what part should you calculate first? Start at the left and go to the right, or go from right to left? Welcome to Puzzle Academy, the place where we can help you to build the pieces to the puzzle of success. Thanks for choosing to spend time with us today. If you are new here, we are happy to welcome you. Be sure to subscribe and follow us on Instagram at puzzleacademy.learn. Warning: calculate them in the wrong order and you get a wrong answer. So long ago, people agreed to follow rules when doing calculations, and they are the order of operations. Do things in parentheses first. Which one is correct? Very good. In the parentheses, we get the sum first of 5 and 3, then we multiply by 4, so we get 32. In the exponents or power roots, before we multiply, divide, add, or subtract. Which of the following is correct? Great! Since we have the exponents in base 2, we simplify first 2 squared. Then we multiply it to 5. So we get 20. After that, we multiply or divide before you add or subtract. Which one is in the right process? Awesome! Since we multiply or divide first before adding or subtracting a number, what we did here is we multiply 5 by 3, followed by adding to 2, so we get 17. Otherwise, just go left to right. What if we have this given? We just need to follow the direction. Divide first and then multiply. So we get 18. Now, the question is, how do I remember it all? The right answer is PEMDAS. Parenthesis first, exponents, powers and square roots, etc. Multiplication and division from left to right. Addition and subtraction from left to right. You can remember by saying, "Please excuse my dear Aunt Sally." Now, we have prepared you an examples for this quest. How do you work out 3 plus 6 times 2? First, we multiply before we add. So we have 6 times 2 equals 12. Then, 3 plus 12 is equal to 15. Now, how do you work out this given? First, we write the given. Then we remove the parentheses. 8 minus 4 is 4. Then after that, we remove brackets. 9 plus 4 is 13. Then remove braces. 8 minus 13 is negative 5. Then we just perform the addition. 4 minus negative 5 is positive 9. What about this example? 5 plus 10 over 3 plus 4. You may not have realized that the fraction bar acts like parentheses. Here is how it works. We put parentheses in both numerator and denominator. Then we perform indicated operation. So we have 5 plus 10 is 15. 3 plus 4 is 7. So we get 15 over 7. What about exponents of exponents? In this example, we all know that exponents are special. They go top down. Do the exponent at the top first, so we calculate this way. Start with 3 squared. So we all know that 3 squared is equivalent to 3 times 3. You will multiply 3 by itself twice, so that is 9. Then, we left us 4 raised to 9. So 4 raised to 9 is 9 times we will multiply 4 by itself. So we get 4 times 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 4. And that is equivalent to 262,144. And that's how we do it. And finally, what about the example from the beginning? Start with the given, then parenthesis first, and then exponent. In the parentheses, we can see that we have 6 times 5 squared plus 3. We simplify first the exponent. So 5 squared, that is 25. So we left us 6 times 25 plus 3. Okay, then we multiply 6 times 25. So we get 150 plus 3. Plus 7 outside the parentheses. Then we add 7 plus 153. Parenthesis completed. Right? So last operation is addition. So we add 7 plus 153. That will give us 160. And that is how it works, the PEMDAS. Hope you learned the concepts about order of operations or the PEMDAS. We want to see you in the next level of this quest. Thank you for listening.